So the one big thing with radicals is that you have to know your multiplication tables. It is a must, okay? And on the top of every paper that we do, I'm going to have you make a big radical sign, and underneath it, I'm going to have you write at least the first 15 perfects. The more that you write them, as you write them, you're saying them to yourself. That will help you learn them. And you always have your calculator to help you. 1 times 1, 2 times 2, 3 times 3, 4 times 4, right? Go ahead and copy those down. There's a couple vocabulary terms that you will need to know when dealing with radicals. Okay? It's the radical sign is the big one. But what's under the radical on the outside of the radical are 2 other words that you need to know. Okay. So I'm going to do a simple one here. We're going to do square root of 25. We all know that the square root of 25 is what? What times what is 25? 5. Okay. When you were in middle school, they made you write 5 times 5. You cannot do that anymore. If you do that, you will make tons of mistakes. The square root of 25 is just plain old 5. That's it. Nothing else. It's not. We know that this means 5 times 5 is 25. Okay. So I'm going to give you another example over here. This is square root. Then there's another thing called cube root. You won't do cube root until you're in Algebra 2, but I'm just using this as an example to explain what index is. So the cube root of 8 means what number multiplied by itself 3 times is going to give me 8? Does anyone know the answer? What is it? 2. Because 2 times 2 is 4. 4 times 2 is 8. So the cube root of 8 is 2. Now, this little number here is called the index. It's telling you what root to take. Well, if you look over here, there is no little number because we don't write it. But you have to know that there's an imaginary 2 there. Because we use it all the time, they don't write the index for square root. So you have to know that, again, when there's nothing written, that the index there is 2. The number under the radical is called the radicand. It's the number that we're trying to find the square root of. Okay, so we'll do a couple examples here. Here's some perfect square roots. The square root of 100 is 10. The square root of 49 is 7. And the square root of 16 is 4. So underneath each of these, I want you to write index and radicand and tell me what each of them are. We'll give you a couple minutes. Now, we don't have you write much on your notes, so that's why again, when you write them, it'll help you to remember and learn what they are. Once you write them, go ahead and fill in what you think the index and the radicand are. Kyle, how about the first one? What's the index on the first one? What's the index on all of these, Kyle? Seth, what's the index on all of these? What's the index? What's the number that's up here? There's no number written, so what do we write? Because these, we're taking the square root of all of them, right? Thank you, Kyle. Okay, so the index on all of those is 2 because it's not written there. We know it means square root. You have to know the index is 2. All right, the radicand for the first one is not 10. The radicand is not the answer. The radicand is the number under the radical. So this should be 100. This should be 49. And this should be 16. Okay? So those are 2 little vocabulary words that will pop up every once in a blue moon. You definitely will see it on your test, but like on the Regents, it will definitely pop up. All right, now this is the way I teach radicals. I kind of use an example of, just because my brother and I so did not get along when we were growing up. Eventually you do get along. I talk about being the firstborn child and the secondborn. I have a lot of kids in my family, but him and I were closest in age, and he always thought he was better than me, and like, you know, we had a lot of sibling rivalry. And because we were so close in age in school, our teachers definitely would tell us, you know, oh, you know, they would compare us all the time. So when we do perfect squares, I talk about when we talk about what two numbers multiply to give you a number, I always say the first one is the perfect one, or the firstborn is always thinks he's the perfect child. So I'm going to talk about that one a little bit, okay? That's when we break down radicals. But first, we're going to go back and we're going to do perfects. If something is perfect, you circle it. Like this is perfect and this is perfect. When it's a perfect square and I circle it, I know that means this number is going to pop out as something else, and we're going to lose the radical sign. So I'm going to bring down my negative that's on the outside. What's the square root of 36? 6. So I call this plain old 6. No radical sign. Here, number 4, 16 is perfect. I put my coefficient on the outside. Here's my perfect child, or my perfect square. This 16 is going to pop out as a plain old 4. And then I'm going to multiply what's left over. Negative 3 times 4 is negative 12. All the rest of them have to be broken down. So because they have to be broken down, we have to figure out the biggest perfect. And I'm just going to rewrite my perfects up here in the black area here so you can see it. Okay. So under each of these, I want you to put 2 radical signs under each of them. The first one is going to be your first child. The second one is going to be your second child. All right. So what I do is at first I look at 18 and I say, where does 18 fall on my list? It falls right about here. And then I test all the numbers because I want the biggest perfect that's going to go into 18. What's the biggest perfect? Well, I know 16 doesn't go into 18, but the next one, 9 does. 9 times 2 is 18. Now, this is like that firstborn perfect child. Again, if it's perfect, we're going to circle it. And your older sibling that thinks that they're so much better than you, what do they do first? They do everything first, right? They have a car first. They go out first. So here is your first, the oldest child. The square root of 9, and he's not staying home. He wants to go out. The square root of 9 is what? 3. Here's the second child. The second child has to stay home because they're too young to go out, right? So it's 3 radical 2. Now, the bigger the number, the more things that will go into it. So for 125, 125 falls right here. You can try to test all of them, divide all of them by 125, but 125 is kind of easy. What goes into 125? 25. 25 is the biggest perfect. It's actually the only perfect that goes into it. 25 times 5. Again, circle your perfect. The square root of 25 pops out as a plain old 5. And that other square root of 5 stays inside the radical. So we can say that's 5 square roots of 5 or 5 radical 5. All right. Here we're going to put a 2 on the outside. And 20 falls here. Can anybody guess what the biggest perfect goes into 20 is? 4 times 5. I'm going to circle the 4. It's going to pop out as a plain old 2. I'm going to bring down this 2 from the outside here first. The square root of 4 pops out as another 2. That's 2 times 2 radical 5. Then you multiply that for radical 5. Now, a lot of people will look at this and say, well, 4 is a perfect square. That can be broken down again. Can that 4 be broken down again? Is my answer really 2 radical 5? Is there a radical sign? Is this a perfect square right here? It is not a perfect square because there is no radical sign above it. The only time they're perfect is when the radical sign's above it. You are done. If you try to say that, oh, this gives me 2 radical 5, it would be the wrong answer. And guess what? The Regents is going to do what? They're going to try and trick you. They're going to put that as a multiple choice answer. And then you're going to question, like, do I have to break it down anymore? Okay, so this plain old 4 is not a perfect square. Radical 4 is a perfect square. Okay, 63. Let's see. 63, if we go in our list, we know 49 doesn't go into 63. Does 36 go into it? No. Does 25? We know doesn't go into it. Does 16 go into 63? In your calculator, do 63 divided by 16. And tell me if it goes in there evenly. No. It does not. Okay. How about 9? Does 9 go into 63? Yes. 9 times 7. And then I bring my 1/9 here on the outside. Now, this is a step that most, as you guys start working and think that this is easy, you're going to say, oh, I can just now multiply 1/9 times 9. You skip a step. You can't do that yet. Because this, remember, this is why I always say circle your perfects. So when you circle your perfect, that square root of 9 pops out as a plain old 3. So then in your calculator, you can do 1/9 times 3, and you're going to get 1/3 as your answer. Radical 7. Any questions on that? Okay, we're going to see. We're going to hit this one, right? Okay, so here, again, Pythagorean Theorem. A squared plus b squared equals c squared. If you want to know if something is square in your home, you're going to use this tool. It's called a T, even though it looks like an L. And it's got like the little ruler marks here, right? Your parents, probably everybody does home improvement projects, okay? So if you want to know if something is at a 90-degree angle, you want to use that little tool to make sure it's square. If you're building something, again, you're going to use this Pythagorean theorem. The C is the most important part because it's the longest side of the right triangle. And your C, there's only one C. A and B are the legs are interchangeable. You can put, it doesn't matter where you put the A or B. Okay? So to see if something is square or forms the right triangle, first of all, you're going to draw this. And you have to say, oh, I know that 13 is my C because it's the longest side. And put 5 and 12 on the other sides. I'm going to label them A, B, and C. Write down my formula. Hopefully you guys remember this from last year or the year before. You're going to plug in, just like my friend I was telling you did, plugs in his 5 squared plus 12 squared, and see if that equals 13 squared. Well, when you square 5, you get 25. When you square 12, you get 144. Does that equal 169? 25 plus 144, yep, 169. So then you have to answer it, yes, 5, 12, 13 forms the right triangle. Now, if they had that little thing explain at the end, you would have to say, yes, it forms a right triangle because I plugged in the legs and the hypotenuse into the Pythagorean theorem. I squared all the sides and found that both sides of the equation are equal. Something like that. Okay? All right, next one. Do the sides 2, 3, 4 form a right triangle? Okay, so Colin, which side is the hypotenuse there? 2, 3, or 4? 4. Why is it 4? It's the longest side. So I know that this is going to be my C. And it doesn't matter which one I make my A or my B. I'll make my B 2 this time, my A 3. And I'm going to plug that into my Pythagorean theorem. I'm going to give you guys a couple minutes. I want you to do it on your own. I'm going to come around and see how you're doing with it. Plug them in and see if both sides are equal. Oops. Come on, you got to write down all your notes, child, all of them. Okay, so let's plug this in. I'm going to have 3 squared plus 2 squared. Does that equal 4 squared? 9 plus 4. Does that equal 16? 13 does not equal 16, so this is not a right triangle. 2, 3, 4 does not form a right triangle. Okay, so that does not form a right triangle. All right, so now this is called testing. Good luck on your operation. This is called testing if something's a right triangle. This next one, you do know how to do it? Okay. You want to just do it for me? You want to put the speaker on? No? You can? You want to try it? Okay. Oh, perfect transit.
Okay, so for this one, we gotta find out what x is. So how we're gonna do this is you gotta it's a squared plus b squared equals c squared. So a squared is 6m, b squared is 8m, and you square those two, and you're gonna get what x is. If you square 6 and 8, you're gonna get 100, and the square root of that is 10. So x is 10. Yeah, sure. Okay, so squared equals 100, and I think I wrote that right. Okay.
Got a 0. Oh, no, you didn't.
Yeah.
There you go.
Yeah, I'm just gonna click.
So again, these are just more types of problems involving your Pythagorean theorem. So we have ABC is a right triangle with right angle at A. So what we need to do first is draw a right triangle. Put our little box in the corner. They told us the right angle is at A. So I have to put A on the corner where the right angle is. And then B and C, does not matter which corners you put those two on, they just go on the other corner. So we got my triangle ABC. We're told AB is 4, so side AB over here is your 4. Side BC is 8. They want us to find AC in simplest radical form. So this is going to go back to what we were just doing on the last page a little bit. So which side here is our C? 8. So then I'll say my 4 is my A. I'll put x in as my B. So A squared plus B squared equals C squared. So that's going to be 4 squared plus x squared equals 8 squared. So then I go ahead and I square my number. So I get 16 plus x squared equals 64. What do we do with our 16? Perfect. Subtract it over. So I get x squared equals what? 48. Now again, it told us up here we had to put it in simplest radical form. That's a big deal. So when I go to take the square root of it, is 48 a perfect square? No, so I gotta find the perfect square that goes into it. What is our perfect square that goes into 48? This is going back to what we were just doing on that first part of the notes. Our perfect square that goes into 48. Perfect, Jordan. 16 times what? 3. If I do 48 divided by 16, I'm going to get a 3. So now, what's the square root of 16? 4. And then 3 stays under the radical. So that side is going to be 4 radical 3. That's our simplest radical form. So number 5, again, solving for x. It involves the 3 sides of a right triangle, so that's our Pythagorean theorem. Which side is our A? No. A, I'll use as radical 13. B, have it be my x, and then my C is my 7. So radical 13 squared plus x squared equals 7 squared. Now when you're squaring a radical, always use your calculator to help you out. Go ahead and type this in. Square root of 13 squared. Let's see what we get when we type that in the calculator. 13. The radical and the square, they just cancel each other out. So I get 13 plus x squared equals 49. Subtract my 13. And I get x squared equals 36. So what does x end up equaling? 6. All right, one more, and then we're done with our notes today. We have in rectangle ABCD. So I'm going to draw a rectangle ABCD. Now, when you label the corners of your rectangle, you need to go around in a circular motion. You can't skip around. So ABCD needs to flow around in a perfect circle. We're told that AD is 4 and CD is 6. They want us to find the length of the diagonal AC. So which part of our Pythagorean theorem are we looking for? The A, the B, or the C? The C. Because remember, this is a 90-degree angle. So that's our C. So we're going to do 4 squared plus 6 squared equals x squared. So 4 squared, 16 plus 36 equals x squared. So what is 16 plus 36? 52. Our directions told us, though, to do what with our answer this time? Nearest tenth, not simplest radical form. So this time we're going to use our calculator, and we're going to actually type in the square root of 52. So using your calculator, type in second x squared 52, and let's get our decimal. 7.28. 1? Oh, 7.21. So to the nearest tenth, that's just one number after the decimal. It would be 7.2.